Hi, everybody. So, in the last lectures, we had discussed about the demand and supply forces in a market economy and resulting price changes in cases of excess demand and excess supply. And we try to understand how price mechanism works in a market economy to determine the allocation of these scarce resources. Now we are at the point to understand better how these demand and supply forces are formed. In order to do that, we have to zoom in into the decision-making processes of the agents or the decision makers. And in order to do so, we will start with the household. And in this chapter, in this lecture, we are going to understand how the household behavior and in particular the consumer choices determine the demand, individual demands in the market, and what is the objective of the household and what are the constraints that the household faces when she makes decisions, economic decisions in output markets first, and then we are going to briefly talk about the decisions, household choices in input markets. So this lecture is going to be a little bit involved. So it is going to be a brief explanation of the household behavior or the way that we analyze these household behaviors in economics. But you should be aware of the fact that there's a deeper philosophical discussions in the context of history of economic thought, which are beyond the scope of this course. So here, my aim is rather to give a brief introduction to the theoretical concepts that is behind the understanding of household behavior and consumer choices. So let's get started. So while we are talking about the decision-making processes, we will be talking about perfectly competitive markets. So we will make this assumption: a perfectly competitive market is kind of a utopic case that it is hard to find in real life, but this helps us to understand the basic motivations behind individual decision-making processes. So unless we say the other way around, when we talk about a market, what we mean is typically a perfectly competitive market. And when we talk about a perfectly competitive market, we assume that it has the following features. The first one is the perfect knowledge, so which simply refers to the idea that all the decision makers in a market have full information about any kind of prices, so the price of the goods and services or wages or interest rates that takes place in a market and the qualities of different types of products so that when they make their decisions, we simply assume that they know everything about the market. So that, as you already can understand, these assumptions that we are going to make about a perfectly competitive market is quite abstract and is quite strong in the sense that it is really hard to find. So you might think that in real life we typically don't have perfect knowledge or perfect information about these kind of economic variables. But to remind you once again, this is a hypothetical world, and we use these assumptions to understand the basic forces behind the demand and supply. So we just take these as given, and there are different fields of economics that studies the cases in which these assumptions do not hold. So typically they don't hold. We know about it, but to understand the basis of economics, we use these assumptions. The second assumption that we make is that every agent or every decision maker in an economy is simply a price taker, which means that um, individual decisions do not have direct effect on the on the market prices. So as a consumer, if I decide to change my demand for a particular good, but we know that as quantity demanded goes higher, or if the demand increases, we know that prices tend to increase. But since I am only an atomic unit in this economy, so I'm very small to have an effect on the market prices. So actually, it is quite a reasonable assumption for many markets. For example, if you think about um, currencies, so my demand for like foreign currencies like dollar or euro, so if I increase my demand as a very small consumer or very small agent in an economy, so my individual demand shouldn't have an effect on the currency rate of dollar or euro, right? So that this price taking assumption also assumes that, so in order for price taking assumption to hold, we assume that there are many or maybe infinitely many households and firms in the market, so that all of the decision makers are very small atomic units, so that they don't have direct impact on the prices, but the prices are formed by this aggregate behavior of the households and the firms. So that in order for this to hold, there are some additional assumptions that first there should be free market entry and exit, so that that none of the firms have market power, and so that the firms or the households, they cannot control prices, so they cannot individually change prices. Another assumption which is less likely to occur in the markets is homogeneity assumption. So which simply refers to the case that the products in a particular market for goods and services are undifferentiated. So if I am talking about Apple market, for example, so there might be different varieties of apples which could have different demand curves, for example. However, if I'm talking about a perfectly competitive Apple market, what I have in mind is a market in which every single Apple is the same. So this is, I mean, this may not seem as an important assumption to make in the first sight, but if you talk about imperfect competition cases, so then there might be different demand curves or different supply curves for uh, similar but not exactly the same products. So in that case, we should take this into account when we study these markets. But the markets we are talking about, we make this assumption if we want the perfect competition assumption to hold. So these are simple. So there are many other assumptions that are not as apparent as these ones, but these are three basic assumptions that we make when we define a perfectly competitive market. So when we talk about whole household choice in the output markets, so what are the basic choices that a household makes in the output markets? Remember that households are on the demand side when we are talking about the output markets, right? So in these markets, the households will have a some kind of financial resources that they decide to allocate across different kind of products, right? So that the first choice that they have to make is how to allocate their scarce income or scarce wealth across these different products, right? So that the first choice that the household have to make is this decision. So if we are talking about the input markets, then there are two basic choice that households have to make. Now, if you're talking about the labor market, then we know that households are on the supply side because they supply their labor, right? So then the second choice that they have to make is regarding their labor, so they have to choose how much labor to supply and such. And Households are also on the supply side when we are talking about the capital markets. Remember that households could save in order to consume tomorrow instead of today, so that they would save these wealth in financial intermediaries or some kind of financial institutions, which will be the supply side for the capital markets. And the firms could use these capital in order to produce more and such. So that this is the third of the choices that households have to make. So it is whether to save or whether to consume what we have today. So in this lecture, the most important question, or the question that we will be more involved with, is going to be the first question. So how do individuals, how do households decide how to allocate their income into alternative goods or services? So to do that, let us remember the determinants of output demand once again. So as we remember from our previous lectures, uh, the demand was affected from the price of the particular good that we are talking about. It was also affected by income and wealth of the household, which would constitute the financial resources that household would have in order to satisfy her wants. So the price of other goods was also important to decide the demand for a particular good, and preferences and expectations were other forces that would determine the output demand. So now let us have a closer look at how does these scarce resources for households when it comes to consumption decisions takes place. So the scarce resources that we are talking about in the context of consumption decisions is defined as the budget constraint. So the budget constraint is the limit. So these are typically financial limits on household choices. So which are set by the income and wealth. So which are the financial resources that household would like to allocate across alternative consumption baskets. And of course, the prices of goods and services also put a restriction on the quantity or the amount of the goods or services that I could potentially buy, right? So that once we know these constraints, so that once we know what we could do with our income for some given prices, so we can talk about our choice set, which is also sometimes called as the opportunity set, which is simply the combinations of goods and services that a particular household could afford for her given level of income or wealth and for given prices of outputs, right? So let us see an example of the budget constraint and what are the components and how it forms the choice set or the opportunity set for a particular household. So in this example, so we can give any names to these x and y variables. So in general, I can call this x-axis as some goods. So in the example in the book, they use time meals, but in general, we could use x1. And on the left-hand side, we see another good now. So don't get confused. So typically we have some prices here, but in this case, when we talk about the budget constraint, we have so another good here. So the example from the book is just club visits. So it could be any other goods or services, let's say X2. So the assumption here is, so remember this simple Robinson Crusoe economy. So we had a similar graph there, right? So there were two alternatives. And so there was a constraint, or there was some kind of production possibilities that Crusoe could perform. So here it is a similar thing. So again, we have a limited amount of budget. So we face some kind of scarcity, and so the graph is between two different kinds of outputs, right? Let's call them x1, x2. So as you can imagine, we can give many examples. So for example, this could be, let's say, apples, and this could be oranges, or whatever they are. So in economics, we typically use two alternatives, because you can populate this example with many other, right? So that in a hypothetical world, you could also analyze, let's say, three, four, five different goods or services, which is closer to the reality. But for illustrative reasons, we usually restrict ourselves with two examples. So when we talk about these kind of graphs or this kind of analysis, try to imagine a world that in which household could only consume. So there are only two alternatives for this consumer or for this household, which are basically x1 and x2. So now let us try to understand how we could define our budget constraint, right? So let me draw another graph on this right hand side, if I can manage to do that. So which is going to look similar, but I would like to sketch this uh, from nothing. So on this x-axis, I have the consumption of the x1 in terms of units. So that, this could be 1 unit of x1, 2 units of x1, whatever your measure of unit is. So it doesn't matter. And the same for x2 on the y-axis, right? So now imagine that we have some prices. Remember, we are working in a competitive economy, so perfectly competitive economy, which means that this household takes the prices of these goods and services as given. So when she enters to the market, when she goes to a supermarket, let's say, so she sees there's a price for X1 and there's a price for X2, and we would also assume that she has some budgets, so some income, some wealth, so some kind of financial resources, which she wants to use for the consumption on X1 and X2. So she wants to buy some milk and bread, and she's going to spend her money in order to buy X1 and X2, but she still doesn't know how many units she would like to buy from it, right? So in order to understand her possibilities, her opportunities, so let us start with this given amount of income, M, right? What would be the maximum amount that she could buy from good X2? So to give an example, let's say she has 100 Turkish liras, okay? So suppose that the price of X1 is, let's say, 20, right? So then the maximum amount that she could buy is simply 5, right? So that she spent all her money on X1. So since the price was uh, 20, then she could buy 5 units of X1, let's say somewhere around here, that she could buy if she spent all her money on, right? So now let's say, so I thought price of X1, a good one, was 20, and let's say this X2 is a bit cheaper, so this price is 10. So again, the same question: what would be the quantity that she could buy from X2 or good 2 if she spent all her income or all her money on buying X2, right? Then it would be simply 10, so that this is the maximum amount that you could buy. So now it is easy to see, so it's rather straightforward to see that if I combine these 2 points, so what happens? So she could also buy any combinations on this line by spending all her money. So to illustrate, so instead of spending all her money on either X1 or X2, so she could buy, let's say, 2 units of X2, and she could buy, or let's say, 2 units of X2, right? And with this money, she could buy, so what with the remaining money, so she could also buy 6 units of X2, right? So there are many combinations that she could prefer, like assuming that we can divide all units into incremental units. So if you connect these 2 points, then what we have is simply called as the budget line, which corresponds to the equation that she spends all her money on buying these goods, right? So that's so if you buy x1 units of good one, so if you multiply the price of x1 with these units, and if you do the same for the x2, so it could be any basket that she could potentially prefer. We still don't know yet, but we know that on this budget line she spends all her money, so that this line actually corresponds to the what we call as budget equation. So once again, on this line, we know that all of the money is spent on buying either X1 and X2, and it shows all the potential consumption bundles, all alternatives that the household would spend exactly her money. So on this left hand side of this budget equation, we have income, or it could be any kind of financial wealth, but we simply call it as income. And on the right hand side, what we have is simply the total expenditure, right? But it is also obvious that if she didn't spend all her money, right? So she could also buy less than these amounts. So she could buy here any combinations that is below this line, she could simply afford. So any points below the budget line is also in the opportunity set of the household. But any point above this budget constraint or the opportunity set is not available, because with the given income and with the given level of prices, so she cannot afford these quantity levels. So if she would like to buy, let's say, 6 units of X2 and I don't know 4 units of X1, so the total expenditure for this amount would be simply 6 times 10 plus 4 times 20, which is 140, which is greater than the income that is available for this household. So then this point is simply not available. But any point on the budget line or below the budget line is available for consumption. So that's what the opportunity set means. So it's basically similar to the production possibilities, shows us all the potential consumption bundles that household could afford with her given amount of income or any kind of financial resources, which we simply call as M, and with the given level of prices. All right. So let us continue. So as I mentioned, so if all the expenditure is, so all the income is spent on buying these goods, then we had the equality. So because we spent, so the total expenditure is simply equal to total income, but the budget constraint is defined by this inequality, because the expenditure, total expenditure, has to be smaller than or equal to total income, right? So that the things, if you are talking about a two good world, so if there are only two goods or services in our world, then the variables that defines our budget constraint or budget equation is simply the price of goods and the quantities that I buy, so that these two forms the expenditures. And of course, we are limited by the income that we have at hand. Okay, so now let us see what happens if any of these variables change. Um, So again, you can see that on the graph, but let us sketch it once again together. So on the x-axis we have x1 again, and on the y-axis we have x2. And let us start with a budget line that is given by some level of income, let's say m over p1, and so this is a more general form, right? So whatever the price of good 2 and good 1 is, and for a given level of income level m, so this is the maximum amount that she could afford for x2, and this is the maximum amount that she could afford from x1, right? So now let us try to understand what would be the effect of a change in, let's say, price of x1. So now let us suppose that there's a new price for good 1, which is simply smaller than the original price. Okay. So the first immediate thing that happens that we could see directly is that, or let us try to give a numerical example. Let's say our income is again 100. So this is our income, right? Then let's say the price of x1 was in the beginning 20, and price of x2 was in the beginning 10. So this corresponds to, again, to 10. This corresponds to 20, and so on. So now let's say that the price of x1 drops for whatever reason in the economy. So we had seen some examples why the price could have dropped, right? So let's say it becomes also 10. So in the beginning, the maximum amount that the consumer could afford from x1 was, okay, this is wrong actually. So this is supposed to be 5, right? So let me correct this. So in the beginning it was 5. So as the price drops, so now she can afford a bit higher, so that now, since the price has dropped, so she can afford 10 units of x1 if she spent all her money here, right? So now let us draw this case, so that with the change in the prices, so the total amount that she could afford increased, and the new budget line actually rotates towards this new amount, right? But one thing that we should be aware of is the following. So with a drop in the price of x1, so the household now have a higher budget, not only for consuming x1, but also she could afford more of x2, right? So to see that, so this was our budget constraint or opportunity set or choice set in the beginning. Now our choice set also includes this additional part, or maybe let me draw this with a different color so that we see it more clearly. Yep. So let's say comes here, right? Okay. So this was our original choice set. Now with a decrease in the price of x1, now we have a higher budget set. But we still don't know, we still haven't talked about how the consumer allocates this budget. We are still talking about the possibilities. So how he could spend, what he could basically afford. So with the decrease in the price, so she can do many things, right? Suppose that this was the original point that the household chose. So with the decrease in the price of x1, she might choose to increase the consumption of x1 only, or she could also choose to increase the consumption of x2 only, right? And she can do many things. So she can choose any different allocation, which is going to depend on the consumer preferences. So far, what we see here that a decrease in the price for X1 does not only lead to purchasing power in terms of X1, but by creating an increase in the choice set, it also allows household to buy more of x2 or x1. So it depends on her preferences. So then, before moving on, let us also try to see, let me use this part, what would happen if the income of the household would change. So again, let's say we have x1 here and we have x2 here. So the change now is kind of different. So suppose that this is our initial budget line. So this point was given by m divided by p1, and this point was given by m divided by p2. So suppose that for some reason, the income of household changes to m prime, which is smaller than the original amount. So now in this case, the change in the budget line is not a rotation, so it doesn't rotate because P1 and P2 are the same. But what happens is that it shifts. So since it's a decrease in income, so it shifts towards the origin, and it's a parallel shift, and we are going to see it, see why it's a parallel shift. But what we see immediately is that so this initial opportunity set has shrinked only to this limited part because the income of household has decreased. So in order to see why it's a parallel shift, we should understand what is the slope of the budget line is. So we can find the slope by looking at this ratio, right? So first we know that it's a negative slope, so let us put the negative sign in the first place. And since this is a line, we could find the slope by dividing this, so the y-axis, with the x-axis on the intersection points, so which would give us the following, which is equal to minus p1 divided by p2, right? So this is the slope of the budget line. And it changes if P1 changes or P2 changes. So in short, if the ratio between P1 and P2 changes, then the slope of the budget line should also change. So if they increase proportionally or decrease proportionally, so let's say in the beginning the price of P1 was 20 and P2 was 10. Suppose that they increase or they doubled at the same time, so that new prices are 40 and 20, then the slope doesn't change, right? So it's similar to a decrease in income. But if this proportion changes, so for example, let's say P2 doesn't change, but only P1 changes, then this ratio changes, which means the slope of the budget line changes, which we had seen already here. So the slope of this original budget line was not same as the slope of the new budget line when the price changed. But here, if the income changes, it doesn't have an effect on the slope of the budget line. So it is a parallel shift in the budget line. So if the income decreases, we see a downward shift or a shift towards origin. Or if it was an increase in the income, then we would see a, so maybe it doesn't look parallel, but it's supposed to be a parallel shift in upward direction. Okay. So this is basically the constraints that household faces when she makes the consumption decisions. But why do we make consumption in the first place, right? So far we had not seen why household chooses any point on. So we still don't know yet which point in this choice set the household is going to choose, right? So to remind ourselves once again, so far what we have learned is that by looking at the prices and the income, we know what are the alternatives that we could afford. So the household could choose any point on the budget line or any point below the budget line, but exactly which point should be answered by the preferences of the household. So in order to do that, we should have an ordering, some kind of ordering that household makes in mind, or in particular, she has to uh, derive some relationship between these different baskets that includes different amounts of uh, x1 and x2, right? So that at point A, we have x1, let's say A, and x2A. So this is a consumption basket, right? Point B is a different consumption basket. So household has to make a decision whether she likes this basket A or she likes basket B. And in order to understand this relationship between A and B, so whether A is preferred to B or whether B is preferred to A, or maybe she's basically just indifferent between A and B. So we have to come up with a concept that allows us to make this comparison. And this concept, so this universal concept of satisfaction is simply the utility. So the utility has a deep philosophical discussion behind it. So we can track this back all the way to ancient Greek philosophers like Aristotle himself. But the way it is used in economics, we owe to more modern philosophers like Jeremy Bentham and the followers of him that discussed how the value is formed in a market, right? So why are some goods or services are considered to be more valuable than others? And the answer that they came up with was the utility. So because um, if we compare a basket A and B, and if we see that the consumer prefers A to B, then a utilitarian would say that the utility from A is simply higher than utility from B. So utility is an abstract concept, so it requires a some kind of abstraction um, to put it more concrete examples. But the way we should understand this is some kind of concept that is used to explain the level of satisfaction that a household derives from consuming a certain good or service. Um, so the utility concept was not enough to explain the values, or when we talk about values, we simply talk about the exchange prices or the prices that you observe in the market. So we have faced some problems or some contradictions if we were to use the total utility that a household would derive from consuming a certain good. So it wasn't enough to explain the values that we observe in the market. So um, what we call as the marginalist revolution in the history of economic thought came after to say that it is not the utility, the total utility that you derive from consuming a certain good, but it is rather the additional utilities that determines the value of a certain good. So marginal utility is simply the utility that is driven from the consumption of the last unit of a good or an incremental unit of good that we consume, so that it simply refers to the change in utility when we consume a additional unit of this good, right? So that suppose that I have a utility, total utility. Let's say this is x1, and let's say this is the utility of x1, right? So this so my utility from x1 as I consume more of x1 might be increasing, but this marginal theory or marginalist theory says that is not the total utility that you compare when you two baskets, but it is rather the additional unit. Suppose that I have one apple, or I just eat one apple. So the total utility from this apple is here. I don't know how many units is this, so we can measure utility in many different ways since it's an abstract term, right? So you can put 100, I don't know, you can put 1 million or whatever. So, but what I am interested in, if you follow the marginalist theory, which we do in modern economics in most of the cases, or in at least in neoclassical economics, so that what really matters is not this total utilities that I drive, but it is rather, so let's say this is one apple and this is the second apple that I consume. So the change in total utility, so let's call it delta U, is the marginal utility of the second apple. And so this change in utility that the marginalist theory puts forward is that the thing that defines the value if you compare different alternatives. So there are some rules that we observe or we assume, so it depends on from which window you're looking at the world, but we still call it as law of the diminishing marginal utility, which simply says that as I consume more of a good, so the utility that I derive from this last unit, so from this additional consumption, is increasing. So be aware of the fact that we are not talking about the total utility decreasing. So it might be increasing still, but what law of diminishing marginal utility says that so the additional, so this change in the utility as I consume more should be decreasing. So which leads to a simply a concave utility function, right? So for example, so this is a concave utility function that I would have in mind so that we can see that, so let's say this is one, and let's say this is the second unit, and this is the third unit. What you could see already is that, so the change in utility, so this is the marginal utility from, so this is the marginal utility from the first consumption, this is the marginal utility from the second unit, and this is the marginal utility from the third unit. So what decreases is these additional units, right? So if we could draw the functions for the marginal utility instead of total utility, so then in the beginning it's quite high, right? Then it is simply decreasing. Okay, so this what the law of diminishing marginal utility refers. So I'm not going to go deep into this derivation of the demand curve by using utilities, but what you should have in mind is that, so this downward sloping demand curve, so remember it was a law of demand, is simply a consequence of diminishing marginal utility. Maybe we can discuss about this more in the Zoom lectures. Okay, so this is another example from the book that, again, the same graph, right? So here we have the total utility that we derive from our trips to some kind of club, whatever it is. But what we should be aware of is the changes in these additional, so the utility from additional consumption, or the change in total utility as we consume more, is actually decreasing, right? So that's why we typically have a concave utility function. So we typically work with concave utility functions. So if we had a convex utility function, for example, that would look like this, then we could see that marginal utility would be rather increasing than decreasing. Okay. So then, once we understood, so this is simple, the most simple introduction to preference. So we make a lot of assumptions that I also make here implicitly, but it is not our direct concern. So just work with these, and these are going to be enough for us to understand how households choose their consumption models. So how do they allocate their income across different uh, bundles, or across different consumption baskets, or across different goods, right? So in order to decide that, households have to maximize this utility, the total utility that she derives from consumption. So in general, uh, again, when we are talking about two alternative or two good world, so the total utility is a function of the consumption of x1 and consumption of x2. So when I talk about the marginal utilities, assuming that I can get the derivative of this function, so the marginal utility from good 1 is simply the derivative of the utility function with respect to consumption of x1, and the same could be told for the second good, right? Because again, so it's the change in the total utility as I increase my consumption by an incremental unit. So if the function is continuous, then I could also say that it's an incremental increase. So I will first state the utility maximization rule. So then we are going to derive it first intuitively, then mathematically, and then graphically, all right? So now what I say is that this equation 2 actually gives us the utility maximization rule. So for a household to maximize her utility, she should allocate her budget or her income such that this condition should hold. So let us try to understand first this intuitively, okay? So let's start one by one. Let us try to understand left-hand side of the equation. So here we have the marginal utility that we derive from the last unit of good 1, and we divide it by the price of the good 1, right? So what does it mean? It simply means that, so how much do I spend to the last unit of good 1? It is actually the price of good 1, right? So if the price is 20, in order to buy this last amount, then I have to spend 20. And what utility do I derive from this last unit? Is the marginal utility, right? So it's given by the marginal utility. So when I divide these two, what I have is the monetary marginal utility, or the increase in the utility by spending 1 unit of money. So let's say 1 Turkish liras or $1 or whatever price unit you are using. So it's the marginal utility that I derive from the last unit of money that I spend on a particular good. So that we can understand that by spending on X1, what would be the increase in my total utility, right? So the condition tells me that, so the value of this last unit of money that I spent on good 1 has to be equal to the last unit of money that I spend on good 2. So to understand why this equality should hold, let us try to investigate a case in which simply this condition doesn't hold, right? So suppose that the monetary value or monetary marginal utility is higher for good 1 as compared to good 2. So if you're the household to decide which good to buy, or which on which good to spend your money on, then you would choose the good for which the additional utility from spending your money is higher, right? So this is obvious. But then what happens as you spend more money on this good? So because of the law of diminishing marginal utility, remember that the marginal utility would decrease as we consume more of this good. So as we start spending our money on the good one, then this marginal utility should go down, right? And what happens at the end, so we keep consuming this good one until these two are again equal, right? So we could also say the opposite. So if it was the other way around, so if the marginal utility from good 2 was higher when we divided by the price of, so when we had the monetary value for in terms of marginal utilities, then we would spend our money on this good 2 until when? Until these two were again equal. So then we can conclude that in order for a household to maximize her total utility, she has to find a sweet point on which uh, the marginal utility from the last money that she spends on good 1 should be the same as the marginal utility that she spends from what she spends on a good 2. And if you have many good Ks, so if we have, let's say, x1, x2, x3, x4, and so on, so then we can also uh, expand this equation to hold for each good that she consumes. Okay. Um, so this actually, by looking at this condition, now we can understand why we use marginal utility instead of um, instead of the total utilities in order to understand the consumption bundles, right? So the one interesting example or one good example to understand this is the so-called water diamond paradox, which basically refers to the fact that although the water is obviously more essential for our lives, why the price of diamond is way higher, right? And the answer is simply behind this utility maximizing rule. So remember what happens here. Um, so let's say water and diamond are the only two goods that we could find. And now we are comparing these two, right? So in order to live, so we have to consume a lot of water, right? And luckily for us, in most of the cases at least, that the water is more available as compared to diamond. So since we consume a lot, the marginal utility of water, so just imagine just one glass of water that you drink without even being aware of it, should be quite low. That for this to be an equality, um, and imagine that the diamond is quite rare in the nature, so that the marginal utility of diamond should be quite high because we cannot find it very easily. And for this equality to hold, the price of diamond has to be too high, right? So, like if we can understand the intuition behind this equation, so we can simply understand why diamond is way more expensive than water. So it is simply because uh, of how rare we can find diamond is. So diamond is very limited in nature, but water is quite available and we consume a lot of it, right? So, I mean, if you would ask a person who couldn't find water for a long time, so who would need a lot of water, then obviously we could see that she would be willing to spend way more money on water rather than the diamond, right? Um, all right. Okay, so now let us try to be a bit more formal and let us try to drive this utility maximization rule more formally by using math. So this was the objective function for the household. So we would like to maximize this utility. So let me also write it here. The household is trying to maximize utility and she's going to choose the quantities x1 and x2 in order to do so, because she doesn't have any control on p1 and p2, and we assume that she's given with some kind of financial wealth, right? And it is subject to, so what is the constraint when she does this? It is she is simply constrained by her income, and it is such that her expenditure simply cannot exceed her income, right? So she cannot spend more than what she has. So this is the constraint. So now we can write, so this is simply a constraint maximization problem, so that we can write the Lagrangian for it. And let's say that lambda is our shadow value. Oops. Okay. So in order to solve that, we have to derive the first order conditions, right? So if you do that for x1, so then it's simply the partial derivative of the total utility with respect to x1, and it is simply this guy here, and we could do the same for x2. Okay, so just to derive this equation, what we have to do is to just rename these two derivatives. But this first derivative here is simply the marginal utility. We derived this before, right? So instead of this, because it measures the change in total utility when I change x1 in a very small unit. So it is basically our definition of marginal utility. And let me write it as equality now. Let's say this is the case. So I make an implicit assumption here, but I mean, if you're interested mathematically in that, so you can ask me what the assumption is, but you can also live without it. All right. So the second for the second term, so this is again the same. So now it's the marginal utility from the second good, and this should also hold. So now if I divide both sides, so what we see is a condition like this, right? And if I simply change these two guys, what I have is as before. Then for this to hold, for utility to be maximized, this is the condition that I should have, right? Great. So as we discussed before, there are two changes that happens that we see from a change in the prices. So let us try to discuss this once again graphically. So let us suppose that this is our initial budget constraint, and we have seen that if the price would drop, if the price for x1 would decrease, then we had seen that the budget line would rotate outwards, right? So there are simply two changes that occurred from this change in the prices. The first is our opportunity set or our choice set has expanded because by using the same amount of income, the same M, the number of units that we could buy increased. And the second thing is that the relative prices, so the ratio between prices has changed because P1 dropped. So this the ratio between P1 and P2 has also dropped. So this refers to two different effects. So this change in the price ratio we call as the substitution effect, because as the price of X1 decreased, so it became more cheaper as compared to X2, so which makes it more preferable, right? So this is called as the substitution effect. And the income effect is due to the fact that the total consumption set, or the total choice set to be more exact, has also increased, so that if she started from a point like this, by keeping her consumption on the same level, she could also just increase her consumption for X2, right? So it depends on her preferences. So this change, or this expansion in the choice set as the price of X1 decreased, refers to the income effect, because with the price decreasing, the purchasing power for all goods has also increased. So uh, these are referred to as two different effects that we see from a change in prices. So to understand household behavior, we can also use the graphical representations a bit better. But in order to do that, we should first define a certain curves that we use a lot in economics, which are called as indifferent curves. So as we had seen, this plot, or let us talk about a particular indifference curve, for example, a particular budget line. So that here there is a countless number of combinations that the household could afford, right? So she could consume A, she could consume B, and such. So that with different utilities, so she might derive different utilities from these 2 points, and given that her total utilities represented by different amounts of X1 and X2, so it could be the case that the basket A might be preferred by the household as compared to basket B, right? Maybe she likes X2 more than X1, so that maybe she could prefer A over B. So we can drive, or we can collect. So let's forget about these 2 points. So we can collect some set of points so these are going to be some kind of special points. So these are going to be a special set of points such that on this curve, let's call it U1, household derives exactly the same utility. So it is possible, right? So what it means is that the utility that she derives from X1A, X2A is exactly the same as the utility that she derives from basket B, and so on. And it's the same for any basket that I derive on this curve. So this curve is called as indifference curve. So that household is indifferent. So if you ask her, would you prefer A or B? She would just say, I don't care. So they are the same to me, right? So that's basically the indifference curve is a collection, or is a set of points that each represents some combination of different amounts of good X1 and X2. And the special thing about these different baskets, or these different combinations, is that they all yield the same amount of total utility. So when we derive indifference curves, or these are actually like more general rules for comparing different units of goods. So we have to make some assumptions. So the first assumption that we have to make is what we simply call as more is better or more is always better. We also call this more technically as local non-saturation. So which simply refers that, remember that because of the law of diminishing marginal utility, we would have concave utility functions. But so the level of concavity could be such that the household might be saturated at some point, right? Then if she keeps consuming more, then she would just hate it, so she would dislike it, so that the total utility would start dropping. So in our analysis, we usually don't like these cases. So we simply say that in our analysis, we assume that as she consumes more, the total utility keeps increasing, although the marginal utility is still decreasing. So for this function, the marginal utility is decreasing, but it never arrives to zero. So it approaches to zero, but it never arrives to zero. So this this assumption is called as local non-saturation, or it simply refers more is always better. And another assumption we have to make refers is called as transitivity, which simply means that your choices has to be logical. So what does it mean? So if you say that I prefer A to B, and if you prefer B to C, then you should always prefer A to C, right? So what is the consequence of this assumption, right? So it simply tells us that so two indifference curves should never cross each other. How can we see that? It's quite simple. So suppose that there are two indifference curves, let's say U2, and let's say that the utility level of this indifference curve is higher than the utility of the other indifference curve, right? So, but they intersect on a point like C. So since C and D are on the same indifference curves, right? So we can say that the utility of point C is equal to utility of point D, right? Because they're on the same indifference curve. But if we compare a point on the indifference curve that corresponds to utility level U2, and if we know that U2 is greater than U1, then by looking at this graph, we can say that so here, let's say this point be, I don't know, G, we know that, and let's say, let us keep the level of x1 the same. So x1G is equal to x1D, but on this point is actually greater. So if this, oh, maybe let me write it better. Okay, so this PD, then we know that the amount of x2 on this point G is higher than amount of x2 on point D, right? So if we know that more is always better, then, and so the amount of x1 is the same, so but x2 is higher, then utility 2, so it also corresponds to something like this, is greater than utility 1, x1D, and x2D, right? But if these two indifference curves intersect, which means that utility 2, x1C, x2C has to be equal, sorry, x2C is equal to U2 x1G, x2G, right? Because they are on the same indifference curve. But this is a contradiction because we know that this point, so the total utility at point G is higher than the utility from point D, right? Because of more is better assumption. But now, since they are on the same indifferent curve, the utility of point C has to be both equal to point D and point G, which is a contradiction. So that's why we say that different indifference curves cannot cross each other. So what we have instead is that we have indifference curves that do not cross each other. And because we know that more is always better, as we go higher, so it corresponds to a higher utility level that U3 is greater than U2, which is also greater than U1. So that in order to have a logical ordering, we have to make two important assumptions. One is more is better, and the second is the transitivity assumption. So we can drive the slope of the indifference curve on a given point. So you can choose one point, and we can try to we can find the slope of this curve. So the slope, as you all know, on this two-dimensional axis is simply equal to the derivative. So the slope for this curve, so we have x2 on the y-axis and we have x1 on the x-axis. So the slope between 2 points might be found as this, right? And we can also, on a single point, we can also use the derivative form, because now we are talking about incremental changes. So by using the total utility, we can drive on a single indifference curve, we can find what this derivative looks like. So in order to do that, we have to use the total derivative. So what I have to take is the total derivative of this total utility function, which is simply equal to the change in x1, total change in x1, and I have to find its effect on the total utility, right? So let me write it down. So that plus the change in x2 multiplied by its effect, so its partial derivative on the total utility, right? So we already know what these things are, right? So I can rewrite this total derivative, the total change in total utility, as in terms of marginal utilities, right? And what I know about the indifference curve is that the total utility does not change, right? So you could increase the amount of x1, but if you want to stay on the same indifference curve, then you have to change x2 such that the utility doesn't change. So I am looking for a point or set of points such that the total utility does not change. So the total change in the utility is actually 0. And by looking at this, I can understand what should be the changes in x1 and x2, right? Then if I rearrange this equation, what I have is the x1 1 is equal to minus, so this is 2, dx2 marginal to 2. Then remember that the slope that I was looking for was dx2 divided by dx1, which is simply given by marginal utility divided by the marginal utility of good 2. So we have a minus here because of the negative slope, right? So in order to stay on the same utility level, if I increase the amount of x1, then I have to decrease the amount of x2 because of more is always better assumption that I have. So we derived the slope of the marginal utility, right, which is given as the minus of the rate of marginal utilities. So this the absolute value of this ratio between marginal utilities we call as marginal rate of substitution, which is similar to this marginal rate of transformation which we derived for production possibility frontiers, which simply tells the rate in which we have to change x1 and x2 in order to stay on the same indifference curve. So that if I increase x1 by a particular amount, let's say that delta x1, so what should be the change in x2 such that I will still stay on the same utility level is simply given by the marginal rate of substitution. So we could call it marginal rate of substitution of x2 in terms of x1, and the minus is due to this negatively sloped indifference curve, right? So another thing that we should be aware of is that the margin, so the indifference curves are not only negatively sloped, but they are also convex. So that when I drove them, so I drove a convex curve, right? And I am going to ask you in the lecture why they are convex shaped, okay? But now the promise was to derive the utility maximization rule by using graphical representations, right? So to hold this promise, let us look at this graph. So let me correct this. So let's say this is x1 and x2, and instead of I, so you could just read m, so it's the same thing. So, and this is P2 and this is P1, okay? So it's the same thing. So the book uses X and Y. I use X1 and X2, so this is P1 and P2. Okay. So now what we have here is the following. So we have a budget line for a given level of income and prices, right? So let me delete these so that you can read, or maybe try to correct them. That in a better way. This is P2, this is M, this is 2, this is x2, this is x1, and so on. So you understand the point, but let me be more accurate. And let's say that these are different utility levels, right? So now remember that Household's objective is to maximize her utility. So she would like to pick the maximum utility levels by looking at these indifference curves, because any indifference curve is a different utility level, right? So, and she is restricted by this constraint, okay? So now let us think which of the points that she should choose. So it is obvious that she, there are many other, there are many other indifference curves here, right? So there's an infinite number of indifference curves. There's also some here. So they're all the same and they never cross each other, right? So it is obvious that the household wouldn't choose a lower level so that any point below these indifference curves shouldn't be preferred. So, but what is, so how should the household choose? So it is now obvious that she's going to choose a point on the budget line, right? So she's going to spend all her money because we know that more is better. But is she going to choose a point like A or C or some other point? So let us compare these 3 points. So which one gives the most utility? So it is point B, right? Because if you compare, so A and C are on the same utility level, But this point B, so it is still affordable because it's on the budget line, but it is on a higher utility level. So that it is on, so the point B drives more utility as compared to point A and C. So, but what is special about this point is the following. As we see that the indifference curve is tangent to this budget line, right, on this particular point. So that what we know about the tangent line to a curve is that the slopes of these two things has to be equal to each other. So if a line is tangent to a curve, then the slopes have to be the same. And what was the slope of the budget line? Was simply equal to P1 divided by P2. And we know that the slope of the indifference curve is simply equal to the, the rates between the marginal utilities. And if you do the same calculation again, so you will arrive the utility maximizing levels. Sorry. So again, we arrive to the same utility maximizing level, right? Okay.